This is a basic model of a hydroelectric power plant. Water enters the system at atmospheric pressure from the source. A large pipe, 60 meters long and 4 meters in diameter, descends a significant hill of 20 meters elevation. There the water passes through a valve before entering the turbine. The turbine drives a generator, producing electricity. The simulation shows some of the relevant system dynamics. Initially the valve is closed and the water in the pipe is at rest. The water pressure in the pipe is distributed between atmospheric pressure, or 0 bar relative pressure, and about 2 bar relative pressure, corresponding to the elevation change of 20 meters. After 10 seconds, the valve is opened and water begins to enter the turbine. A drop in pressure along the pipe is visible, along with a quick increase in pressure in the water volume just before the turbine. The valve is controlled by this signal block. It begins opening at 10 seconds and takes another 10 seconds to fully open. After 50 seconds of simulation time, it begins to close and is fully closed 10 seconds later. The resulting volume flow rates through the pipe, valve, and turbine can be seen in the lower diagram. The flow rates are nearly identical. It is only once you zoom in significantly that you can see minor variations. When the valve is open, the water flow drives a turbine. The turbine is connected to an element modeling the mechanical inertia. At the beginning of the simulation, the turbine is already spinning, gradually slowing down due to this friction element. Shortly after the valve is opened at 10 seconds, we can observe the turbine begin to speed up again, back to its nominal speed of 200 RPM. After 20 seconds of simulation time, the generator receives a signal to start producing electricity using the turbine power. The generator is controlled in such a way that it changes the amount of torque it is withdrawing from the turbine so as to keep the turbine at its nominal operating speed of 200 RPM. After 50 seconds, the generator is turned off and stops withdrawing power, and the valve begins to close. Without the resistance of the generator, the turbine accelerates for a few seconds until the reduced water flow from the closing valve is no longer enough to maintain its speed. In the lower diagram, we can see in red the amount of power produced by the turbine. In green, the turbine power actually converted into electricity via the generator, and in blue, the power loss due to friction.